Hello, welcome to today's lesson. Today we are looking at the theorem that states that an exterior angle of a cyclic quadrilateral is equal to the interior opposite angle. Right, so in this case we have a cyclic quadrilateral. Let's say it's A, B, C, D. Now we have angle C1 as an exterior angle. Let's just have C1 and C2. Right, we are required to prove that the exterior angle, which is C1 in this case, equals to the interior opposite. You can see the opposite angle to C is A. So we are required to prove that C1 equals to A. Right, so we start proving from the theorem that we did about opposite angles of a cyclic quad. We remember that angle C2 plus angle A equals to 180 degrees. These are the opposite angles of a cyclic quad. So remember, the opposite angles of a cyclic quad are supplementary. Again, if we take C1 and add it to C2, we also get 180 degrees because these are adjacent angles on a straight line. They are the adjacent angles on a straight line, so when we add them we get 180. Right, so from here we can conclude, because if we take A and add it to C2 we get 180, and when we take C1 and we add it to C2 we get 180. Or if you want to even make it more simpler, we can write that from first statement. You can say angle A is 180 minus C2, angle C2. From statement number 2, you can say C1, angle C1, all these are angles. You can say angle C1 equals to 180 minus C2. So if you take C2 that side here and C2 that side here. Now, from this, it's so clear that it means angle A equals to angle C1. Why? Because they both equals to 180 minus C2. So that concludes the proof of the theorem. We wanted to prove that angle A equals to angle C1. That was the required to prove. We wanted to prove that angle A and angle C1 are equal. So an exterior angle of an exterior angle of a cyclic quadrilateral is equals to the interior opposite angle. Right, now I want us to look at the conditions for a cyclic quadrilateral. The conditions for a cyclic quadrilateral. Now, for a quadrilateral to be cyclic, it has to satisfy one or all of these conditions. Number 1, all the 4 vertices must lie on the circle. All the 4 vertices must lie on the circle. On the circumference of the circle. All the 4 vertices must lie on the circumference of the circle. right? If not, then we go to number 2. Then the opposite angles must be supplementary. The opposite angles must be supplementary. In other words, if we see a quadrilateral and there is no circle around it, but somehow we are able, if this angle x and this is angle y, we are able to prove or show that angle x plus y is 180, then we conclude that this is a side liquid. In other words, we conclude that there is a circle around this. So that's a condition for a side liquid. So opposite angles must be supplementary. So when they say to you, prove that the angles, prove that maybe ABCD is a side liquid, one of the things to consider is to prove that the opposite angles are supplementary. That is, when you add them, they give you 180 degrees. So number 3, an exterior angle or the exterior angle must be equal to the interior opposite angle. So in other words, if we have a quadrilateral somehow, and then they say we are able to prove that this angle, which is an exterior angle, let's say this angle is x and that this angle is x, then we can conclude that this quadrilateral here is a side liquid because the exterior angle equals to the interior opposite angle. So likewise, if they ask us to prove that a particular quadrilateral is cyclic, all we need to consider is, let's check the exterior angle, whether we can prove that the exterior angle equals to the interior opposite angle. So if that is the case, then this particular quadrilateral is a side liquid, meaning there is a circle around it. Right, number 4. If angles subtended by the same arc, if angles subtended by the same arc or chord are equal. Right, so in this case we have a situation. So let's say we have this diagram here, ABCD, and we want to prove that ABCD is a side liquid. As long as we can prove that angle A equals to angle B. So if angle A equals to angle B, or even angle D equals to angle C, then ABCD is a side liquid. So we concluded that, okay, this thing is a side liquid, there is a circle around it. So it means when they ask us to prove that a particular diagram or a quadrilateral is a side liquid, we need to consider these 3 conditions. The first one, we can do nothing about it, because if all the 4 vertices are on the circle, it means definitely that is a side liquid. We don't have to prove it. But then when they say prove, we look at number 2, 3, and 4. So in other words, we check whether the opposite angles are supplementary. So if the opposite angles are supplementary, it means it is a cyclic quad. If the exterior angle equals to the interior opposite angle, then it is a cyclic quad. Or if the angles that are subtended by the same arc are equal, then it is a cyclic quad. So for us to prove that it's a cyclic quad, we need to prove one of these three. Thank you very much. So please don't forget to like, subscribe, and share.